Hello everyone. In this video, I will focus on Physics, October-November 2023, second version of multiple choice question papers. In this exam, the A was given 27 or above. B was from 24. Grade threshold for C was 20. D was 17. And the passing mark for exam, the E was given 14. This is all out of 40, right? And in this video, I will explain all the 40 questions. And I have separated timeline into 40 different portions. So you don't have to go through all the video. If you are confused about a certain question, example, let's say you want to focus on question number 35, you can directly go to that question. Alright, let's start. Question number 1. A student estimates the maximum speed of some different moving objects. Which maximum speed is not a reasonable estimate? I know the sprinter's speed. The average the Olympic runners run 100 meters normally in 10 seconds, right? Or a little below. So average speed is 100 divided by 10 meters per second. Or if I divide this number from 1000, you can write the same number in kilometers per second, which comes into 0.01 kilometers per second. Now if you look at this number, this is 10 times larger than the accepted number, right? So this is impossible. So actually you don't have to go through all the options. Just pick something you are very sure about and check that one first. Question number 2. Which quantity is an SI based quantity? We are talking about quantities, not units. Let's think about those quantities. We have length, mass, time, current, electric current, and thermodynamic temperature, right? And amount of substance. Just check which one of these is given. Force, Newton. Second, be careful about second. Second is a unit. We are talking about quantity. So time, because time is one of the SI based quantities. So answer is D. A student takes measurements to determine the constant acceleration of a modeling car moving from rest in a straight line. The measured values with their absolute uncertainties are shown. And the student uses this equation to calculate the acceleration. They ask what is the acceleration and its absolute uncertainty. Means they are asking about delta A. Alright, let's try. First, let's use the equation S equals AT squared over 2. A equals 2S over T squared. So let's plug in the numbers. 2 times 16.5, 15 squared. You can use the calculator. So you get 0.15 meters per square second. Now I will write the same equation one more time. A equals 2S over T squared. I am writing the equation for fractional uncertainties, delta A over A plus or minus delta S over S plus delta T over T. But be careful, don't forget there is square 2. So put 2 at the front. And here there's another trick to play. Now I am plugging numbers. Delta A over 0.15. Where does that come from? Because we calculated it before, right? Equals plus or minus what uncertainty of displacement is 0.1. So 0.1 divided by 16.5 plus time is uncertainty of time is 1. divided by 15. Now, if you look at these two numbers, you should notice actually this one is 10 times larger than this one, roughly, even more. So, you don't have to actually, what I am going to do now is, I am going to ignore this one. I'll think about it later. So, delta A equals plus or minus 1 over 15. Oh, I forgot that 2. 2 should be there. 2. So, 2 over 15 times 0.15. Obviously, this comes to 0.02 meters per square second. I understand delta A should be, by adding this small value, little more than 0.02, right? So, I am looking for that answer. So, you don't have to worry about adding all the numbers and spending your time. Focus on the biggest one and then think, okay, the answer should be a little bigger. So, answer is D. An aeroplane is moving at a constant speed in a straight line at an angle theta to the horizontal. Four forces act on the aeroplane: thrust force, weight, lift force, and resistive force. Which two equations must be correct? Alright, this is a typical question where you have to resolve the weight into two perpendicular directions. Alright, so this side is W sine theta. The perpendicular component is W cosine theta. You can do it with memory, or you can think about it. This is theta, this is 90 minus theta. So this part is theta. You can make a right angle triangle, and you can do it step by step. And if the plane is not accelerating, the forces along the inclined angle should balance out, right? So T should be equal to R plus W sine theta. Again, to the vertical, this is along the inclined angle. To the perpendicular direction, L must be W cosine theta, right? Now let's check which one is the correct answer. L equals W cosine theta, that's right. And T, okay, answer is A. Question number 5. What is the definition of acceleration? Definition is delta V over delta T. How do we read this? Rate of change of velocity. So that's just a question where they check your memory. So answer is D. An astronaut on the moon, where there is no air resistance, throws a ball. The ball's initial velocity has a vertical component of 8 and horizontal component of 4. The acceleration of free fall on the moon is 1.62, not 9.81. This is not the Earth. What is the speed of the ball 9 seconds after being thrown? Okay. There are two different types of motion within projectile motion, right? So I am going to write V equals U plus AT for vertical motion, and I have a direction, so I have to strictly follow this arrowhead, right? So we don't know. U is 8. You don't have to resolve because vertical speed is already given. And acceleration is minus 1.62 because acceleration is downward times 9. You get is 6.58, or let's call it 6.6 meters per second, and it's a minus value. It means actually it is downward. And now we have a speed 6.6 downwards, and 4 meters per second has not changed. The reason being it is horizontal. It has no effect from vertical forces, right? So let's find total V. V equals 6.6 squared plus 4 squared square root. This is Pythagoras theorem, right? So So this gives 7.7 meters per second. Answer is B. Here, let's first mark all the forces acting on these objects. Let's take G as 10 for easy calculation. Then we can adjust our answer. So if this is 0.5, this is 5 Newton, and upward there is a tension. And there's a tension on the pulley. Normally we don't care about this tension on the pulley. This is not our focus. And the same tension, same string, so that happens on the mass on the table also. And on the table there is a friction F. And with all this, acceleration is 2 meters per square second. This mass goes on the table, the mass goes forward to your right, and the bigger mass moves downward at same acceleration because they are connected by the same string. Now I am trying to write equation for the 0.5 kilogram mass. F equals ma. Downward 5 minus tension. Mass is 0.5. Acceleration is 2. Okay, from here tension equals 5 minus 1 is 4 Newton, right? But that's not what they are asking. They are asking about the friction, but we need this tension to find the friction. So what I am going to do, I am going to use it later. It means I am going to write F equals ma for 0.2 kilogram mass. So tension minus F is 0.2 times 2. Tension was 4, right? 4 minus 0. F equals 0.4. Obviously F equals 3. Now the thing is, you can say this answer is not given because we took G as 10. So if you take 9.81, around this should be 3.6, either little smaller or little bigger. So 3.5. Answer is A. A resultant force causes an object to accelerate. What is equal to the resultant force? This is again checking your memory. Newton's second law equation is net force is change of momentum over change of time. So this is the definition of resultant force. This is called rate of change of momentum, right? So the change in here, this one talks about momentum, the change in momentum of object per unit time. This is another way of saying the same thing. So answer is C. An object falls from a stationary helicopter and reaches terminal velocity. What happens to the acceleration of the object between leaving the helicopter and reaching terminal velocity? Let's consider only 2 points where the object is being released and where at the end the object reaches terminal velocity or moves at terminal velocity. At the beginning there's only one force, the weight of the object, because the speed is 0. The drag force depends on the speed. There's no speed, there's no drag force. At the end, the gravitational force mg will be cancelled by drag force. So at the end, acceleration is obviously 0 because no net force, Newton's first law. Similarly, at the beginning, acceleration is net force divided by mass, right? So the force here is mg divided by m. You will get g, or 9.81. So if you start with 9.81 and comes to 0, it means obviously your acceleration with time, acceleration is decreasing, right? How it is decreasing? Is it a curve or a straight line? Does not matter. It is a decreasing graph. So answer for question number 9 is B. two balls of mass m and 2m traveling in a vacuum with initial velocities 2v and v collide with each other head on. After the collision, ball of mass m rebounds to the left with v. What's the total loss of kinetic energy? Loss we are talking about. So let's draw here. After the collision, this ball will move to the left at the speed of v. Let's find out what will be the speed of this bigger ball at let's say v dash. By conservation of momentum, at the beginning momentum is 2m times v plus 2m times v this way equals, we are taking the momentum to the right as positive. So after collision, minus m times v and plus 2m times v dash. If you look at this one carefully, first I have to change the direction of this one. So what I will do, 2mv minus 2mv, because I change the direction of arrow, equals minus mv plus 2mv dash. V dash is v over 2. Now we need to find the change of the kinetic energy. So we have to find before, we have to find the after, and we have to find the difference. So change of kinetic energy is half. Kinetic energy does not have a direction, so you don't have to worry about arrowheads here. mv squared for the first situation. Hold on, it's a mistake. This is not v. This should be 2v squared, and then the other bigger mass, this one, kinetic energy is half 2m times v squared minus afterwards half m v squared plus the other one is half 2m v over 2 squared. If you like, you can take this half mv squared all together out. So here it will be 4. Here it will be, on other place it will be 2 minus 1 plus this will be half. If you look at this calculation very carefully, this will be 6 minus 1.5. 4.5 means 9 over 2. This will come to 9 mv squared over 4. Answer should be C. A force F is applied at an angle 45 to the door handle at distance D. What's the moment of the force? For this question, we need to first resolve this force into two parts. One horizontally, and the other component will be vertical. And when you do it right, you should get, if it is 45, if this is F, this should be F cos 45. Horizontal part will be F sin 45. Now moment is force times perpendicular distance. Here, this F sin 45 part is actually no use because it goes through the pivot. So the moment is F cos 45 times D. It is F times cos 45 is 1 over square root 2 D FD over square root 2. Answer should be A. Question 12. A couple consists of two forces, each of magnitude F, that act on opposite direction in the same plane. The perpendicular distance between the two forces is D. What's the torque? Torque of a couple is one of the forces times perpendicular distance. So in this case, it should be simply F times perpendicular distance D. Answer should be C. The diagram shows an experiment to determine the force exerted on a ball by a horizontal airflow. The ball is suspended by a light string and weight is given. The deflection of the string from the vertical is 30 degrees. The ball is in equilibrium. What is the force? First, let's mark all the forces acting on this object. This is the force from the wind, and then we have tension from the string, and then we have the weight of the ball, which is 0.15 Newton. We can resolve this tension into two parts. This will be, if this is 30, this will be T cosine 30. Horizontally, it will be T sine 30. So for equilibrium, horizontally, I can write T sine 30 must be equal to F. Vertically, T cosine 30 should balance the weight of the ball, or you can write is 0.15. Let's take these two equations as equation 1 and equation 2. If you divide 1 from 2, sine 30 over cos 30 is F over 0.15. 0.15 tan 30, you will get 0.087 Newton. Answer should be B. Two solid cylindrical objects X and Y are held fully submerged in a liquid. The objects have the same volume. That's very important to highlight this one. The objects have same volume. Okay. And the density of the material Y is twice the density of the material X. Both objects are stationary. Which statement is correct? Let's think about one by one. Let's focus on statement A first. The force due to liquid acting on the top surface of X is greater than the top surface of Y. Let's think about A. Force is pressure times area. But pressure in a liquid is H rho G times area. It means the depth. H means the depth. But if you look at X, X is not very deep X surface, but it's also a small area. So from here we can understand force on X is actually smaller than force on Y surface. So this answer A is wrong actually. So let's focus on answer B. Answer B says the pressure difference due to the liquid between the top and bottom surfaces of X is same as that for Y. Alright. Pressure difference is about H rho G, but here H means the height of the object. But here Y has smaller height. So delta P of X is actually bigger than delta P of Y because the height is smaller. So answer B is also wrong. Let's focus on answer C. Answer C says the upthrust acting on X is same as upthrust acting on Y. What is the equation for upthrust? Upthrust is up U equals V rho G. We need to understand these symbols properly. U equals V rho G. V stand for the volume of the object. Rho stand for the density of what? Density of liquid, not the object. And this is volume of object. So if you think about this one, at the beginning they said they have the same volume. Okay, this is same. They are both in the same liquid, so upthrust has to be the same. So upthrust is same for both of objects. That's correct. Answer is C. An electrical car travels at a constant speed of 70 kilometers per hour for 80 kilometers on a horizontal road, and energy E is used. The total resistive force acting on the car is proportional to V squared, speed squared. Okay. Assume that the electric motor is 100% efficient. How much energy is used for the battery when the car travels at a constant speed of 60 kilometers per hour for the same distance? Alright, let's try to understand energy or work. Work done is about force times distance, right? Okay, but we have to think about the force on the car. If the car is moving at constant speed, horizontally there are two forces. One is the thrust from the engine, and the other one is the drag force from the air and from the road, but we are mainly focusing on air here. And this one here is kv squared because it's proportional to speed. Now I am going to change this equation. So work done is force times distance. Force is thrust equals drag, kv squared times distance, right? Let's think about first situation. First situation, work done or energy used is speed is how much? It is, hold on, I can't see, 70. Okay, k 70 squared times distance is 80. Don't worry about SI units, we are just comparing the numbers. Second situation, let's say E dash is k times 60 squared, distance is still the same. If you divide, now I come here, 2 over 1, E dash over E is 60 over 70 squared. E dash, you will get 0.73 times E. Answer is A. What is meant by efficiency of a system? This one again checks your memory. Efficiency is useful work to total work ratio. Remember, the numerator is the useful work, the denominator is the total work. Based on that, the useful energy output from the system divided by the total energy. That's good. This is the total energy on the denominator. So answer should be C. When an object of mass m is raised to a vertical height delta h, the gain of gravitational potential is delta EP. Delta EP and h are related by the equation. We are all very familiar with this equation. They ask the definition of which physical quantity is needed to derive this equation. Let's check what is work done. Is force times distance into the direction of force. Okay, in this case, if you are lifting an object, let's say the object has mass m, so the force we have to balance this mg with another force, right? So for the force we have to use here is mg times the distance is delta h. So this is how we get mg delta h. This is what stores as gravitational potential energy. So this one needs the basic definition of the work done. So for this question, the answer should be D. Three identical springs, each with the same spring constant, are connected together in 4 different arrangements. Which arrangement has the largest combined spring constant? Combined spring constant. What is spring constant? Spring constant is, you can use K as the symbol, is F over X, or in simple intuitive way, it is the stiffness of an object. And by intuition, by day-to-day experience, we know if you put 3 springs parallel, the combination becomes stiffer, right? Even more difficult to pull apart. So this must be the one with the highest spring constant, and on the other hand, this spring is to get an extension from this spring, it is much more easier. So the spring combination with the largest spring constant or most stiff is answer B. The force extension graph for a wire is shown. Which row could identify the labels X, Y, and Z? They are talking about limit of proportionality, elastic deformation, and plastic deformation. So, we need to understand first the spring. What is happening to a spring is elastic. It means if you let it go, it will get back to the initial shape and size. Elastic, and in physics, plastic means exactly opposite meaning of elastic. It means over here in this region, if you let it go, it will have a permanent deformation, something like this. So, and the boundary between these two, this is called limit of proportionality. So let's check. Let's start with C. Limit of proportionality is Z. This is correct. This is correct. But on the other hand, about region of elastic deformation is X. Answer should be D. X and Y are 2 points on the surface of a water in a ripple tank. A source of constant frequency generates a wave which travels past X and Y, causing them to oscillate vertically. What is the phase difference between X and Y? Okay, let's focus on background knowledge. Let's think in a wave, we have 2 points. And let's think one point is here, the other one is here. They are X distance apart. And the wavelength of this wave, lambda, from here to here, and the phase difference between these 2 points, delta phi, is 360 for lambda. How much for X? These are interconnected this way, right? Now let's look at our situation. The wavelength here is marked, and XY distance is X to this point is half wavelength, this is a quarter wavelength. So in this example, X should be taken as 3 lambda over 4. So by that equation, delta phi is 360 degrees for lambda. How much for 3 lambda over 4, right? So 360. A transverse wave on a rope has wavelength lambda and t. The graph shows the variation of the displacement of the particle of the rope with distance in the direction of travel of the wave at t equals 0. The particle x is labeled, which graph shows the variation of the displacement of particle x with time. We understand this type of oscillations have interesting graphs, like they are sinusoidal graphs, right? They can be sine or cosine depending on where the motion is starting from. One thing for sure here is that we know the motion starts from 0. So it has to be either positive sign or minus sign graph, right? One of these. Our job is to find out which way X will move right after this moment. So what we are going to do is, we are going to draw next wave pattern. So it means everything has moved just a bit forward. The energy has gone bit forward. In that case, X must get into the new wave. So X must be moving downwards. Based on that, out of these two, X is going to the negative direction, means making negative displacement, means the answer should be the one I am marking in red color. So this answer should be A. A source of sound wave is moving at a constant speed directly towards a stationary observer. The speed of sound is given, real frequency is given, the observer hears frequency 650 Hz. What's the speed of the source? Now for source moving towards a stationary observer, the equation is f dash equals f v speed of wave minus speed of the source, right? Let's use this equation. 650 is the frequency you will hear. The real frequency is 480. Speed is 340. 340 minus speed of the source. By we can remove this 0. So 65 times 340 minus 65 speed of source is 48 times 340. So speed of the source is 340. 65 minus 48 divided by 65. If you check this calculation, you can use the calculator, of course. Speed will come into 89 meters per second. Seems like a racing car or something very fast, right? A student is investigating two electromagnetic waves x and y in a vacuum. Wave x has a wavelength 5.2 10 to the power of minus 7. Wave y has a frequency of 9.4 gigahertz. Which principal region of the electromagnetic spectrum contains wave x and y? Best is to think what are the wavelengths you know. We know 4 to 7 times 10 to the power of minus 9 meters, or 400 to 700 nanometer is visible light, right? So if you look at this first number, it is definitely in visible region. Now the good news is you don't have to worry about the second data. The data given about y is not even relevant. Why? If you look at this, only answer C has visible as the answer for x, so you can simply go and pick answer C. A plane polarized light wave of intensity I0 is incident normally on a polarizing filter. The initial intensity of the transmitted wave is 0. Second polarizing filter is then inserted between the source and the first filter. Its transmission axis is 45 degrees to the transmission axis of the first filter as shown. What is the intensity of the transmitted wave from the filter combination? Very good. This one thing very important to understand is this light has already been polarized, so we can use Malouf's law. So let's think here intensity coming out of the first polarizer is I1. Let's think the intensity of light coming out of the second polarizer I2. So I1 is I0 cos squared, angle between two polarizing filters to polarizing axis is 45, and this I1 will be the starting intensity for the second polarizer. So I2 equals I1, again polarizing angle difference between first and second filters is also 45, cos squared 45. So by combining these two equations, I2 equals I0 cos squared 45 times cos squared 45. This becomes I0 cos 45 is 1 over square root 2 to the power of 4. I0 over 4. Answer should be C. What can explain how stationary waves are formed from progressive waves? Stationary waves. What do we know about stationary waves? Stationary waves, we know, are made by two waves. They are moving to opposite direction and interfering, and they must be identical, right? Identical waves moving opposite direction and interfering or doing superposition, right? So answer is C. A pipe has a length of 2 meters. It is open at one end and closed at the other end. Stationary wave is set up within the pipe. There are 4 nodes and 4 antinodes within the length of the pipe. What is the wavelength of the sound wave? Let's try to draw the stationary wave produced here in a more visually appealing way. So here we can see two loops. Each one of these shapes are called loop, right? So 2 loops is a 1 wavelength. Here there is another 3/4 of a wavelength. So lambda plus 3/4 of a lambda is 2 meters, the length of the tube, right? We don't need meter here. So I can write this is 7 lambda over 4 is 2. Lambda must be 8 over 7 or 1.1 in meters, right? So the answer should be B. A teacher is explaining diffraction to a group of students. Which piece of apparatus is most appropriate for teacher to demonstrate diffraction? First, we need to understand what is diffraction. Let's think we have a gap in a barrier. The wave is blocked everywhere, but it can pass through this gap, right? And a set of wave fronts are approaching the gap. And we know if the gap size is almost similar to the size of the wavelength, the wave can spread out, right? This is called diffraction. By experience, we know the teacher always uses ripple tank. You can ask, what about a rope, a stretched string? These are for stationary waves. So answer for question number 27 is B. Coherent light of constant wavelength is incident normally on a double slit. Interference fringes are formed on a screen that is a fixed distance from the double slit. The screen is parallel to the double slit. The separation of the slits is varied. Which graph best shows the variation with slit separation A of the spacing x of the interference fringes? Okay, what is the equation for Young's double slit interference? X equals lambda d over A, right? And here they say these two values are constant, they don't change. Okay, let's rearrange this equation. X equals lambda d times 1 over A. Here they said they will take this one as y-axis, A as x-axis. So this is like y equals a constant times 1 over x shape graph. Do we know this graph? xy is a constant graph, looks like this. So where can we see this answer? It's on answer A. Light of wavelength 690 nanometer passes through a diffraction grating with 300 lines per millimeter, producing a series of bright spots, or we call them maxima. What's the total number of bright spots? What's the diffraction grating equation? D sine theta equals n lambda, right? For maximum order, it means this is the angle we are talking. So if you want to see everything on this direction, you have to change theta into 90, right? So d over lambda is that maximum number. Let's write it as n naught. Now there's another problem. What is d? D is length over number of lines. We want to find size of one line, right? So I change length 1 millimeter into meter and 300. Now we can use this one here. So n naught is 1 times 10 to the power of minus 3 over 300 over 690 times 10 to the power of minus 9. If you do this calculation right, you can use the calculator, you will get 4.8. But we have to change this one into 4 because we are thinking about dots. So it can't be 4.8. It has to be rounded to the lower number. So total is, we have 4 dots on the left. Similarly, we have 4 dots on the right, and then we have at the center, right? So 2 times 4 plus 1 should be 9. Answer should be D. A fine mist of oil droplets is sprayed into air. As the oil droplets leave the nozzle of the spraying device, they can become electrically charged. What is not possible value for the charge of an oil droplet? There's something about electric charge. Charge of an electron is connected by a full number, or you can say charge is Q over 1.6 10 to the power of minus 19 must be a full number, right? Now if I look at this one, if the answer A, charge is Q, so N can be 0. But if you look at part answer B, charge is 1 times 10 to the power of minus 19, charge of an electron 1.6 10 to the power of minus 19. This is something like 6 point something, right? 6.2. That's not a good answer. It's impossible. If we check answer C and D, they give n equals 3 and n equals 5. So the answer B is impossible. It has to be a full number. So answer is for question number 30 is B. In this circuit shown, a fixed resistor X is connected in series to the battery and a variable resistor. The power dissipated in X is 7.2 when the current is 3. Power is increased by 50%. What's the new current? Let's talk about electric power. Power is VI or I squared R or V squared over R. Very importantly, here resistor is a fixed resistor, so we should choose P equals I squared R, because we can ignore this one because resistance does not change in this situation. So first situation, power is 7.2, 3 squared times R. This is the first equation. Second situation, 7.2 times 1.5, because 50% higher. Current is I squared, R does not change. If I divide 2 from 1, I'll get 1.5 is I squared over 3 squared. If you do the calculation, 3 times square root 1.5 gives you 3.7 ampere. Answer is B. The potential difference across a metal wire is kept constant. The length L and the diameter D of the wire are both varied. The type of metal is kept the same. How the current in the wire is related to I and D? Let's think about it. We know any kind of conductor follows V equals IR, but R, resistance of a wire, is rho L over A. Cross-sectional area of a wire is a circle, so area is pi R squared. R stands for the radius. Or if you think about diameter, the same equation can be changed, pi d squared over 4. Now I am going to use this one into this equation. V equals I times rho L pi d squared 4 goes up. So let's rearrange this equation. I equals pi V 4 rho and d squared over L. Now I am going to ignore all these parts because these are constant. So current is proportional to diameter squared. Current is inversely proportional to length. These are the two conclusions we can make for this situation. So answer should be C3. A student sets up a circuit. The circuit diagram shows how the positive and negative terminals of a voltmeter are connected to the circuit. The voltmeter has an initial reading of that is positive, which changes, if any, in temperature and light intensity would cause the voltmeter reading to decrease. So we have this one on the right upper corner is a LDR. On the left bottom corner, this is a thermistor. Now, best way to approach these questions is you can put some numbers. Example, 8 volt here, 2 volt here. So voltmeter reading is 8 minus 2, 6 volt, right? So if you want this number to decrease, you can do two things. You can decrease this 8 volt or you can increase this 2 volt. Now on the right top corner, for a LDR, if you want voltage to decrease, this resistance has to decrease. It means light intensity has to increase. Similarly, on the left bottom corner, if you want thermistor's voltage to decrease, resistance has to decrease, for that temperature has to increase. So by looking at these two, we can see temperature and light intensity both in this process have to increase. So the answer should be A. Some resistors and a battery of electromotive force E and negligible internal resistance are connected. Which statement is correct? Again, let's put some numbers. Let's say this is EMF is 20 volt. Maybe this resistor has 2 volt potential difference, 10 volt, 6 volt, maybe this also 2 volt. We can see 20 equals 2 plus 10 plus 6 plus 2. So obviously the voltage gets added, right? 35. Kirchhoff's first law is a consequence of conservation of which physical quantity? Alright, let's try to draw a situation where Kirchhoff's first law applies. Let's think 20 ampere comes here. If 10 goes here, if 8 ampere goes here, how much current will go here? We know it is 8 is coming and 10 is going, 8 is going, I is going. So this should be 2 ampere. So this is based on current or current. Current means charge divided by time. So it is actually conservation of charge. Charge has to balance out coming charge, going charge per every second. So answer is A. If you have two resistors, let's say if it is 6 ohm and the other one is also 6 ohm, how much is the total resistance? It is 6 over 2, right? You can do the same technique for 3 or 5 or any number of identical resistors. So let's use this one here. In this example, they are asking about total resistance. So this resistance here is 3 of 6 resistors parallel. So I can write it as 2 ohm, right? 6 divided by 3. This also 2 ohm. And this 6 divided by 6, 1 ohm. So we can reduce this situation into only 3 resistors. One is 2 ohm, the other one is 1 ohm, the other one is 2 ohm. In series resistors R total is, just add them together, right? 2 plus 1 plus 2, 5 ohm. Answer is B. In the circuit shown, a battery of negligible internal resistance is connected in series with 2 fixed resistors R1 and R2. The circuit is to be used to test whether the electromotive force of a particular cell is 1.5 volt. The cell is connected between the terminals X and Y in parallel with R2 and in series with a galvanometer. Which statement about the test is correct? Now, I suggest you forget about this cell. Just find how much is the voltage across R2. So voltage across R2 is 20 divided by 20 plus 60 times total voltage EMF is 6. If you do the calculation, you will get the answer 1.5 volt, right? Now, so this cell has to be 1.5 volt. So it's very important this stays 20 ohm. So, and when this is 1.5, this is resistance voltage across R2 is 1.5. The galvanometer should show 0 reading. So non-zero reading on the galvanometer means cell has an electromotive force 1.5. No, that's wrong. It means these two numbers are not equal. That's what these two numbers are not equal means galvanometer will show a reading. So this is wrong. Answer A is wrong. The battery does not need to have an EMF 6 volt. If battery has any other number, the voltage across R2 won't be 1.5. So this is also wrong. We need that 6 volt. Question number part answer C. The cell may be connected either way around terminal between X and Y. That's wrong. It's very important that cell is connected the same way as the driver cell. This and this should have negatives and positives in right order. The galvanometer does not need the scale calibrated in amperes. What we need to see in the galvanometer is whether it shows 0 reading, positive reading, or negative reading. We don't care how much is the reading. So calibration is not important. Answer should be D. Two nuclides are different isotopes of the same element. Which statement about the nuclides is correct? Again, this type of question can be understood easily if you take two isotopes. Let's say sodium 23 and 11, and I take sodium 24 and 11. Now the number at the bottom represents number of protons, or you can say number of electrons. There are no electrons in a nucleus, but this is the same number when it comes to the atom, right? So let's check the answers. The neutral atoms of the nuclide have same number of electrons. That's right. Both of them have 11 electrons. Nuclei of the nuclides have different number of protons. Wrong. They have 11. Nuclei of the nuclides have same number of nucleons. That's wrong. Nucleon means this number. They are different. Nucleon number, or you can call it mass number, are different. And nuclei of the nuclides have the same number of neutrons. That's wrong. They have first one has 12 neutrons, second one has 13 neutrons. The charge to mass ratio of a particular particle is given by the equation charge over mass. The value of R is determined for an alpha particle, beta plus particle, or positron and proton. Which list shows the particles in order of increasing magnitude of R from left to right? Okay, let's think about it. Okay, alpha, beta plus, and proton 1, 0. Let's think about the R value for them separately. Here I am going to use symbols. Alpha is plus 2 charge, mass is 4 unified atomic mass units. Beta is plus 1, mass is 0.0001 roughly U. Proton charge is 1, mass is U. It's obvious that this number is the biggest because it is divided by very small number. So, and second must be this, because this is divided by 1, but this is divided by 2, cancel 2, so divided by 2. So beta plus must be the biggest. Let me write here, beta plus must be the biggest, then proton, and then alpha. This should be the order, so answer should be B. Question number 40 is just a question to recall your memory. Proton, by memory recalling, I understand proton is up, up, down. There are 2 up quarks and 1 down quark. Neutron is up, down, down. As long as you remember this, you can get the answer C. So this is all about 2023 November paper 1-2, and thank you very much.